Good morning guys and welcome back. In this video, we will learn how to do correlation using Excel. But in order to do this, let's define what is correlation. Basically guys, the correlation is used to determine if there is some relationship between variables. For example, if they are proportional, if they are inversely proportional, or if there is any other relationship between them in the positive or negative way. In fact, correlation is used to predict the response of a certain variable by changing another variable. Now here, for example, in this graph, we can predict that there is a strong positive relationship between salary and the years of experience. And this is because only obvious relationships can be detected by looking directly to the graph. So here, this relationship is very clear. What if this relationship is not obvious and I need to find if there is a relationship between them? How can I relate them and how can I find the correlation? For example, guys, if I have these two graphs, it's obvious that in the first graph here, I know that the marks are proportional to the study time in the positive way because it's obvious, guys, that they are going together. However, in the second graph where I have some scatter of points, I'm sure that there is no correlation between them. So this is an obvious example of no correlation between X and Y. In a certain case, I can have a correlation, but that is not clear. Like for example, in the first graph, the technology investment versus profitable growth. I can see that there is a correlation and it is basically positive. Positive means they are going together. It is not a straight line, so the slope is not constant, but I can see, guys, that there is a positive correlation between them. Now, in the second graph, where the price is drawn versus the quantity, I can see that there is a negative correlation, and it is a straight line, so they are inversely proportional, and this is logic, guys, because I know if the quantity is decreased, then the price will increase because I have demand on this quantity. And whenever this quantity is increasing beyond the demand, of course, the price will decrease. In fact, guys, the correlation is specified by what is called Pearson's correlation coefficient or correlation coefficient, and its symbol is R. This R can show me the degree of association between two variables. For example, here in the first graph, R is equal to 1 because in fact my variables are lying on a straight line, straight increasing line. Now in graph B, R is equal to -1 because my variables are basically inversely proportional. All my variables are lying on a decreasing straight line. In graph C, R is equal to 0 because as you can see there is no correlation. There is an absence of correlation. Now if there is a relationship but it is not a straight line, then R should be between -1 and 1. R should be different than 0 and it should be between -1 and 1. So basically, guys, R varies from +1 or from -1 to 1 and it is equal to 0 when there is no correlation. Let's take this example. In this example, I have the ice cream sales versus the ambient temperature. So I can logically predict that there should be a relationship between them because in fact the ice cream sales increases whenever I have a very high ambient temperature. So let's do this using Excel and find out what is the coefficient of correlation between these two variables. The first step, of course, is to select data analysis and then to select the correlation. And then I have to indicate my input and then I can see the output, which should be the coefficient of relationship R or of correlation R. Let's do it using Excel. Guys, here I have the ice cream sales versus temperature. And I need to do the correlation. So I have to go to data analysis. If you don't have this data analysis, you have added from options add-ins as in the previous video. And then guys, I need to select correlation. And then I have to click on OK. And then I have to indicate the input range. Guys, here the input range is not one column or one row. No, they are two columns because I have to find the relationship between ice cream sales and ambient temperature. So that's why, guys, I'm going to select these two columns. And then I have to say that they are grouped by columns and not rows. And since I have selected the titles with these two columns, I will click on labels in the first row. Now, I don't want to see them in a new worksheet. I want to see them in the same worksheet here. So I will select this cell as my output range, and then I'm going to click on OK. So guys, as you can see, Excel will provide me with a table. And this table is basically a symmetrical matrix. And it has the size of 2 by 2 because I only have two variables. And you can see, guys, that the first variable, temperature here, is correlated, of course, with temperature by a coefficient of 1. So obviously, and ice cream is correlated with ice cream with a coefficient of 1. I don't want to see these values. What matters for me is this value here, 0.957507. This is R, this is the coefficient of correlation. And this means that 95.7 or almost 96% of my variables are correlated together. Which means this is a very strong correlation because R is very close to 1. And since it is positive, this means that the ice cream sales increases with temperature. And you can see this basically by drawing this at the same graph. Using scatter points. So guys, 96% of these points are basically correlated together, and this is because of this coefficient. So basically, guys, in order to know if they are correlated together, I need to search for this coefficient of correlation, because in fact, this coefficient of correlation will give me the relationship between these variables. Since R here is 0.95, this means that 96% of variables are correlated together, and this is a very strong relationship between variables. Thank you.